Hello everyone, hope all of you are doing well. Today we are going to discuss important question answers from the chapter Electric Charges and Fields of grade 12. Chapter 1 Electric Charges and Fields. When a glass rod is rubbed with silk, glass rod becomes positively charged and silk negatively charged. This happens because material objects under normal conditions are neutral. That means they do not show charge effect because they contain equal amount of positive and negative charges. During electrification, a transfer of charge takes place via the transfer of electrons. The body that gains electron become negatively charged and the body that loses electron become positively charged. Here glass rod loses electrons, that's why it becomes positively charged, and silk gains electrons, that is why it becomes negatively charged. In a similar way, when a plastic rod is rubbed with fur, plastic rod becomes negatively charged and fur becomes positively charged. Now we can move to next question. When a glass rod is rubbed with silk, charges appear on both. Explain how that observation is consistent with law of conservation of energy. According to law of conservation of charges, for an isolated system, the net charge always remains constant. The charges can be transferred from one part of a system to another, but net charge will always remain constant. So in this case, when two bodies are rubbed, the body which loses electron will become positively charged and which gains electrons becomes negatively charged. The two bodies thus acquire equal and opposite charges. The charge is only transferred from one form to another. The next question is, what do you mean by grounding or earthing? Suppose when a charged body is brought in contact with the earth, then what will happen? Then all the excess charges pass to the earth through the connecting conductor, right? This process of sharing the charges with the earth is called grounding or earthing. Next question, what do you mean by quantization of charge? Charge occurs in nature as discrete entity. One packet of charge is called quantum charge. It is represented by E. And charge of a body is always an integral multiple of one electronic charge, that is Q is equal to plus or minus NE, where N is equal to 1, 2, 3, etc. The next question is, how many electronic charges form 1 coulomb of charge? Here we have to calculate the number of electronic charges to form 1 coulomb of charge. From the quantization of electric charge, we have Q is equal to plus or minus NE. Here Q is 1 and E is the charge of electron, that is 6.02 into 10 raised to minus 19 coulomb. So that we can calculate value of N as N is equal to Q by E. Then we can substitute the values of Q and E. Then we will get 1 by 6.02 into 10 raised to minus 19. So that will be equal to 6.25 into 10 raised to 18. The next question is, how many electrons constitute an electric charge of minus 16 microcoulomb of charge? Here also we can use the equation of quantization of electric charge, that is Q is equal to plus or minus NE. Here we have to find N, that means N will be equal to Q by E. Here we have Q as minus 16 into 10 raised to minus 6 coulombs and E value is 1.6 into 10 raised to minus 19. Then we will get the answer. That means N is equal to Q by E. That will be equal to minus 16 into 10 raised to minus 6 divided by 1.6 into 10 raised to minus 19 coulomb. The next question is, state Coulombs law. The idea of electric interaction between point charges was introduced by Coulomb, and the force of attraction or repulsion between two stationary electric charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. That is F is equal to K into Q1 Q2 by R square. Now we can move to question number 9. This is a numerical problem. The question is, what is the force between two small charged spheres having charges 2 into 10 raised to minus 7 coulomb and 3 into 10 raised to minus 7 coulomb placed 30 centimeter apart in air? So here the quantities given are two charges, that is 2 into 10 raised to minus 7 coulomb and 3 into 10 raised to minus 7 coulomb. And the distance between them is 30 centimeter. We have to calculate the force between the charges. How we can find the force between two small charges? Yes, we can apply Coulombs law. So directly we can apply F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. Here there is no conversion of charges, so that we can directly substitute the values. For exam, you have to mention the values, that is Q1, Q2 and R. Q1 is equal to 2 into 10 raised to minus 7 coulomb, Q2 is equal to 3 into 10 raised to minus 7 coulomb, then R is equal to 30 centimeter, that we can write as 0.3 meters. Then we can substitute in the equation. F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. So that will be equal to 1 by 4 pi epsilon 0 is 9 into 10 raised to 9, right? So that into Q1 2 into 10 raised to minus 7 coulomb into 3 into 10 raised to minus 7 divided by 0.3 the whole square. When we calculate, we will get the value as 6 into 10 raised to minus 3 Newton. Now the question number 10. A body of mass m is charged negatively. State whether the following statements are true or false. First one, during charging there is a change in mass of the body. The statement is true because the mass is not at all conserved. Now the second statement is the body can be charged to 2.5 E, where E is the charge of an electron. This statement is false because the charges are always quantized. That means the charge possessed by any body will be an integral multiple of plus or minus E. That is, Q is equal to plus or minus NE. Therefore, the charges will never exist as fractions. The third statement is, while charging the body by induction, new charges are created in it. The statement is false. In the case of induction, the same charged body can be used to charge any number of bodies without any loss to its own charge. Now the last statement, the force between two charged objects is less when there is a medium between them than in vacuum. The answer is true because in the case of Coulomb interaction, when we introduce a dielectric medium in between the two charges, the force becomes F medium is equal to F air divided by epsilon R. This means that when we introduce a dielectric medium, the force decreases. Now we can move to the next question. Define electric field. Electric field refers to a region surrounding a charge where its influence is felt, or the space where charges or charged bodies electrically interact is called electric field. So in short, we can write down electric field is the region around a charge where its effect can be felt, or E is equal to F by Q. The next question is, write the unit of electric field. The unit of electric field is Newton per Coulomb or volt per meter, because E is equal to F by Q. Here force is Newton and Q is in Coulomb, so that the unit will be Newton per Coulomb, or we can write down volt per meter. Now we can move to the next question, that is, derive the equation for electric field due to a point charge. So first of all, we can consider a point charge Q placed in air or vacuum. Let Q0 be the test charge placed at a point at a distance r from Q. So we have to place a test charge Q0 at a distance r from Q, and the diagram is as shown in the figure. And then we can calculate the force experienced by Q0 by using Coulombs law. That is, F will be equal to 1 by 4 pi epsilon into Q0 by R square, because the two charges are Q and Q0 and it is separated by a distance r. In order to calculate the electric field intensity at P, we have to divide the force with Q0. That is, E is equal to F by Q0. That will be equal to 1 by 4 pi epsilon into Q by R square, because that Q0 and Q0 will get cancelled. So this is the expression for finding the intensity of electric field at a point due to a point charge. Hope it is clear to you. The rest of the questions we can discuss in the next video. If you like my videos, please like, share and subscribe. Thanks for watching.